Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young. Section 5, Projective and Metric Geometry. In projective geometry, no distinction is made between ordinary points and points at infinity, and it is evident by a reference forward that our assumptions provide for no such distinction. We proceed to explain this a little more fully and will at the same time indicate in a general way the difference between projective and the ordinary Euclidean metric geometry. Confining ourselves first to the plane, let M and M' be two distinct lines, and P a point not on either of the two lines. Then the points of M may be made to correspond to the points of M' as follows. To every point A on M, let correspond that point A' on M', in which M' meets the line joining A to P. See Figure 2. In this way, every point on either line is assigned a unique corresponding point on the other line. This type of correspondence is called perspective, and the points on one line are said to be transformed into the points of the other by a perspective transformation with center P. If the points of a line M be transformed into the points of a line M' by a perspective transformation with center P, and then the points of M' be transformed into the points of a third line M' by a perspective transformation with a new center Q, and if this be continued any finite number of times, ultimately the points of the line M will have been brought into correspondence with the points of a line Mn, say in such a way that every point of M corresponds to a unique point of Mn. A correspondence obtained in this way is called projective, and the points of M are said to have been transformed into the points of Mn by a projective transformation. Similarly, in three-dimensional space, if lines are drawn joining every point of a plane figure to a fixed point P not in the plane pi of the figure, then the points in which this totality of lines meets another plane pi' will form a new figure such that to every point of pi will correspond a unique point of pi', and to every line of pi will correspond a unique line of pi'. We say that the figure in pi has been transformed into the figure in pi' by a perspective transformation with center P. If a plane figure be subjected to a succession of such perspective transformation with different centers, the final figure will still be such that its points and lines correspond uniquely to the points and lines of the original figure. Such a transformation is again called a projective transformation. In projective geometry, two figures that may be made to correspond to each other by means of a projective transformation are not regarded as different. In other words, projective geometry is concerned with those properties of figures that are left unchanged when the figures are subjected to a projective transformation. It is evident that no properties that involve essentially the notion of measurement can have any place in projective geometry as such. Hence the term projective to distinguish it from the ordinary geometry, which is almost exclusively concerned with the properties involving the idea of measurement. In case of a plane figure, a perspective transformation is clearly equivalent to the change brought about in the aspect of a figure by looking at it from a different angle, the observer's eye being the center of the perspective transformation. The properties of the aspect of a figure that remain unaltered when the observer changes his position will then be properties with which projective geometry concerns itself. For this reason, von Stout called this science geometrie der Lage. In regard to the points and lines at infinity, we can now see why they cannot be treated as in any way different from the ordinary points and lines of a figure. For in the example given of a perspective transformation between lines, it is clear that to the point at infinity on M corresponds in general an ordinary point on M', and conversely. And in the example of a perspective transformation between planes, we see that to the line at infinity in one plane corresponds in general an ordinary line in the other. In projective geometry, then, there can be no distinction between the ordinary and the ideal elements of space. Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.